Tech AI Open, unleashing the power of AI and robotics technology.
So Microsoft recently released their new research paper in which they present something called Orca 2. Now this is a follow-up to what they released before, which was Orca, and this was something that we did a video on before. 5 months ago, they released something called Orca. Essentially, it was a large language model that was pretty good in capacity that took everyone by surprise and managed to match the capabilities of chatgpt. Now, however, they're back again with, of course, Orca 2. And this is teaching small language models how to reason. Now, there's one section of this paper where I think that we do get some kind of breakthrough in the kind of methods that we are using to train these large language models. And with the discussions online about this kind of training, I want to propose to you the idea why this is definitely going to change everything. So here's the thing about Orca 2 that sets it apart from other models, is that when you read this paper, is that they did do something different. I think it's called step-by-step recall, then generate, then reason, recall, generate, direct answer, etc. So they have all of these various reasoning techniques for every different prompt. And essentially, the reason Orca 2 is very, very good and why it's so cool and amazing, and I'm going to get into some of the real reasons later, is because one of the reasons is because Orca 2 significantly surpasses models of similar size and attains performance levels similar to or better than those models 5 to 10 times larger. So the thing about Orca and what we've seen about Microsoft research is that Microsoft are focusing what seems to be on large language models that are small but really, really capable. You see, Orca is only 7 billion parameters, which is tiny in the comparison of things. You see, I think when we look at some of the other large language models like GPT/ChatGPT 3.5, that one has 175 billion parameters, but Orca is only 7 billion parameters and manages to accomplish nearly many of the feats that ChatGPT does, which is why this model is truly, truly interesting. Now, interestingly enough, what this model is, this model is open source, so you can use this right now. If you do want to get the weights of this model, you can go over to this page and you can see that it's Microsoft Orca 2 13 billion parameters. There's a 13 billion version and then there's a 7 billion version. So that should be something that I've seen people testing on Twitter, and it's actually really good. So why this is like, you know, so crazy is because the way that they train this model as well introduces some new techniques that we haven't seen too much, but we are going to get in that. Now, what is Orca 2 based on? Orca 2 is based on, of course, Llama 2. So Orca 2 is built upon the Llama 2 model family, and of course it does retain some of its limitations as well as the common limitations of LLMs. But I think it was really interesting that it was based on Llama 2, because when we compare it to the other models, you guys are going to see that it has the reasoning capabilities that are comparable to much larger language models. You can see to evaluate Orca 2, we use a comprehensive set of 15 diverse benchmarks that correspond to approximately 100 tasks and more than 36,000 unique test cases in zero-shot settings. The benchmark covers a variety of aspects, including language understanding and common sense reasoning, multi-step reasoning, math problem solving, reading comprehension, summarizing groundness, truthfulness, and toxic content generation and identification. Now, of course, you can see that on these benchmarks that Orca 2 does surpass Llama Chat 2, even which it's based on, and it does also surpass Wizard LM. Now, yeah, it would have been interesting if we actually got to see what they compared this against, because they only did compare it against Llama 2 and Wizard LM, so it would be nice to see many of the other models. Now, I'm not saying that they cherry picked this, because I'm pretty sure they didn't, but some of the findings are really, really cool, because remember, these other models are, you know, really a lot bigger. So if they're able to get these smaller models to be more efficient and better reasoners, then we have a serious future in our hands. Now, this is where it starts to get interesting, and this is where I need you guys to pay attention, because this is where the true stuff does come through. So it says Orca's performance significantly surpasses models of similar size, and it also attains performance levels similar or better than those of models at least 10 times larger, which is of course models that are around that 70 billion parameter model, showcasing the potential of equipping smaller models with better reasoning capabilities. Orca 2 models exhibit limitations, and of course what's also interesting was that the way that they trained Orca 2 could be applied to different base models. Okay, now they only used Llama 2, and the reason I'm talking about different base models is because Llama 2 is good, but there are other base open source models that are far superior that I'm going to talk about later, and I think it's really interesting because those are the base models that we do have. If you take a look at the large language model leaderboard, you can see right now that there was a new open source king, and this one was called YI 34 billion parameters. Now, it does absolutely insane. It crushes the benchmarks, but that's what I'm saying, okay? So imagine now using the way that we trained Orca 2 to, be even more effective. Can we apply it to some of these open source models and then get even more effective? Because a lot of these models, some of these are trained in many different ways, and it's intriguing to see how we could do this. So essentially, the main breakthrough for Orca 2 was the synthetic dataset. So it says here the Orca 2 is trained with an expanded, highly tailored synthetic dataset. The training data was generated such that it teaches Orca 2 various reasoning techniques such as step-by-step processing, recall then generate, recall reason generate, exact generate, and direct answer methods, while also teaching it to choose different solution strategies for each different task. So the reason that this synthetic data is such a large breakthrough is because of the fact that this allows us to achieve scale. It allows us to achieve scale on a level that we haven't seen, and I can guarantee you all that this is probably one of the large stepping stones that we need to explore when it does come to looking at AGI. You see, the problem with a lot of the data sets that we do collect is that you actually do need to get a lot of data. And the problem is, okay, the problem with collecting data is that it is very, very hard to collect, human generated data. And when we look at what, GPT-3 was trained on, it was trained on, I think, 45 gigabytes of training data. It says GPT-4 was trained on, 45 gigabytes of training data, and GPT-3 was trained on 17 gigabytes of training data, which essentially means that, if one of the main bottlenecks is data, then Microsoft research showing us that training on a new synthetic data set and providing these outstanding results shows us that this is where we need to look. Now, Microsoft research aren't the only ones that are looking into synthetic data sets because, of course, as you know, this is data that is created by AI themselves and is essentially just generated. Now, the reason that this is really cool is because others in the field have also started to say this, and many people are looking at the previous lessons that we did talk about. So Dr. Jim Fan says that it's pretty obvious that synthetic data will provide the next trillion high-quality training tokens. I bet most serious LLM groups know this. The key question is how to sustain the quality and avoid plateauing too soon. The Bitter Lesson by Richard Sutton continues to guide us in AI development. There's only two paradigms that scale indefinitely with compute, learning, and search. It's true in 2019, and at the time of writing, it's true today, and I bet it's going to be true until the day that we solve AGI. And essentially what he means by that is that if we want to get like a trillion high quality tokens, we're going to need to make sure that we are able to generate high quality synthetic data. And I'm pretty sure one thing that they did, I don't remember if it was GPT-4 or GPT-3, but I'm pretty sure that they exhausted a lot of the highest quality data that was available. And it was Sam Altman or Greg Brockman that was talking about how the fact is that they know that for the other large language models like GPT-5 and further iterations, that if they've collected every single data source, on planet Earth, which trust me when I tell you guys, it's not that much, okay? You can fit it on like a USB drive, like all of the data if you have it just as text. Essentially what we need now is we need to be able to generate a continuous stream of new data that we can use to train these models so that we can have them in different ways. And I'm going to show you later why this is crazy. Now, the Bitter Lesson is a really, really, really key insight into why we need synthetic quality data. And when you see this, you're going to be like, okay, this is so true. So the Bitter Lesson essentially is broken down into 5 parts. And essentially, it says that general methods are effective. The primary lesson from 70 years of AI research is that general methods leveraging computation outperform other approaches due to the exponentially decreasing cost of computation. Then essentially, it talks about the transition and the case studies, okay? And this is the key important part. I'm going to show you guys a GIF that basically illustrates why synthetic data will be what changes everything. So it says, historically, AI research often assumed constant computation availability, focusing on leveraging human knowledge, okay? The key part here is human knowledge. However, as computation power increased, the focus shifted to leveraging this growing computational capability. So as you know, before it was all about human knowledge and human power, but you have to remember, over time, compute has increased. We get faster, GPUs, we get faster processing power, we get more RAM, we get everything is just becoming more and more efficient. And of course, this is attributed to Moore's law, okay? But this is where we have to shift over to ensure that we know that we can utilize this compute, which is going to be more effective. And one of the things is, as well, is extensive search and computational power. So the thing about this is that there is a case study which shows us that training on data that AI creates itself essentially creates a feedback loop of kind of like self-improvement to the point where we can get that next level in AI. And that's why there is such a focus on synthetic data. So I'm going to show you guys this GIF right here.
Thank you so much for watching this video. Please get in touch for more upcoming